All right, chapter 12 is where we're at right now. We're going to start exploring some three-dimensional solids today. Starting off, a polyhedron is a solid bounded by polygons. It's basically a three-dimensional figure where all of the sides are polygons, flat surfaces. Each flat surface, each polygon is known as a face of the polyhedra. Every line segment where the faces meet are called edges. And then the corners are called, each one's called a vertex. The plural is vertices. Uh, I use the term polyhedra, which is the plural of polyhedron. And there's different types of polyhedra. There's prisms. There's prisms. I think I just said prisms twice. There's prisms. There's pyramids. There's also uh, solids that are not polyhedra because they're round, like cylinders and cones and spheres. We're going to be talking about all five of these types of things in the next week or two, or a few weeks if you include spring break. But let's start with polyhedra. We can classify polyhedra by how many faces they have, very similar to how we classify polygons. Polygon, we use a lot of the same prefixes that we're going to use for polyhedra. The first thing is for polyhedra, you can't have less than four faces. That four-faced polyhedron is known as a tetrahedron. Tetra for four. You may have heard that tetra prefix when you did your chemistry class, some sort of chemistry thing. I remember with molecules that are in the shape of a pyramid, they called tetrahedral or something like that. Anyway, a five-sided or five-faced polyhedra is known as a pentahedron. Six is hexa, hepta for seven, octa for eight, nona for nine, all the same prefixes you're used to using, 5 through 10. A decahedron is 10. 11 you often see as a undecahedron. I've also seen hendecahedron. 12 is dodecahedron. And then 20 is a pretty common one, so we should probably emphasize that one as well, the icosahedron. So those are the ones I'll expect you to know everything on that list. On that original slide of five different solids, we said that two of them were polyhedra, a prism and a pyramid. They're all flat surfaces. So let's talk a little bit about those. A prism is a polyhedron that has two congruent and parallel faces that have to be polygons. They could be any polygon. And those parallel congruent faces are known as the bases of the prism. And I have a little website here that I'll post a link to in the Edpuzzle video that maybe I'll click on one just to show you. It's pretty cool that you can do, you're probably going to want to mess with on your own. So I'll post the link so you can. And it allows you to kind of manipulate these things. For example, this is a triangular prism. There's two triangles that are the bases. And then you'll notice that all the non-bases are quadrilaterals. More specifically, they're parallelograms. And in many cases, they're rectangles, assuming they stand up straight. Here's a rectangular prism. This one has rectangular bases and rectangular or parallelogram non-bases. Those non-bases are going to be called lateral faces. More on that later. Pentagonal prism, two pentagon bases, and then you could see all the lateral faces are parallelograms, or in this case, they look like they're actual rectangles. Here's an octagonal prism, two octagons. All the non-octagon faces are rectangles. And then we could even click on these nets that show you how they look unfolded. So this is a cool little website that I'll link you to so you can mess with this yourself. So that's what a prism is, two parallel congruent bases that are polygons connected by rectangles for the most part. And then we could say the same thing about a triangular pyramid, except a pyramid only has one base that can be any polygon. And then the lateral faces, the non-bases, those are triangles always. And I have that same website here for pyramids, and I'll link you to this one as well. Here's a rectangular pyramid, a rectangular base. The lateral faces are triangles. Pentagonal pyramid, pentagonal base, the non-base lateral faces are all triangles. And you could do it with any polygon. And here's the nets. They always look kind of the same, where there's this polygon connected by triangles. And again, I will link you to this site so you can mess with this yourself, because I think that's a neat way to do hands-on without actually having them in your hand. So here's some examples. Tell if it's a polyhedron. If so, name it and find the number of faces, vertices, and edges. Well, this is a prism with rectangular bases. And the thing that's kind of interesting about a rectangular prism is you can use any pair of the parallel congruent rectangles as bases, and then the other four faces become lateral faces. So I would call this a rectangular prism, which also could be classified as a hexahedron. It has 6 faces. And then it says to find the number of faces, vertices, and edges. Well, it's got 6 faces. That's why I called it a hexahedron. It's got 6 faces. Let's count the vertices. It got 1, 2, 3, 4 up front, and 1, 2, 3, 4 in the back. That's 8 vertices. And then the edges of the line segments, it's got 4 long ones here, and then 4 on each little rectangle. So that's 12 edges. And there's going to be a little formula coming up that we're going to always be able to compare the ratio, or compare the number of faces, vertices, and edges. More on that soon. Why don't you try this one? What would you classify this as? Well, hopefully you said it was a hexagonal pyramid, which, if I asked you to give a polyhedron name with the prefixes, that would be a heptahedron. And now we can count the faces. It's got 6 around the sides plus the base. It's got 7 faces. It's got 6 vertices down here plus the 1 up top. It's got 7 vertices. And it's got 6 edges down the sides plus, or what did I say? 6 edges down the sides plus the 6 on the bottom. That's 12 edges. And again, we're going to talk about the formula that compares those in a minute. And this, well, that's a cone, which is not a polyhedron at all. And the reason is because it's round. No rounded things for polyhedron. Just like no rounded things for polygons, no rounded things for polyhedra. That is not a polyhedron, but it is a cone. So you may have noticed on the last slide when we named the rectangular prism that when I was figuring out how many faces it had 6 faces. The base was a rectangle, and then the polyhedron had 6 faces. So the base had 4 sides, but the polyhedron had 6 faces. There's something to that. With the pyramid, the base had 6 sides, but it had 7 faces, and there's something to that too. Prisms have 2 bases, so I always want to add 2 to the number of faces when I count the number of sides of the base. I add 2 to figure out how many faces a prism would have. And since a pyramid has 1 base, I always add 1. And that's what this next slide's talking about. If we want to classify a polyhedron, we can add 2 to the sides to get prisms and 1 to get on pyramids. Let me try to clear up what I'm saying here. A pentagonal or pentagonal prism. I'm going to draw that. A pentagonal prism. Well, pentagonal prism has 2 pentagon bases, and this is where I wish I had my smart board. I can draw a lot better on that. But here's 2 pentagon bases, 1, 2. And I usually try to make them a little flatter than normal because I want it to look 3D. I didn't even do a great job there. Then I connect all the common faces to make it look like a pentagonal prism. And if you're counting these, it's got 1, 2, 3, 4, 5 lateral faces, 1 for each side of the base. And then there's the 1, 2 bases. So plus 2 bases, and I end up with 7 faces, making it a heptahedron. The quick way of doing that was thinking, since the bases are pentagons, that means there's 5 lateral faces. And then I have to add 2 because it's a prism, because there's 2 bases. For a pyramid, I do the same thing, except there's only 1 base. So when it's a hexagonal pyramid, let's say, like they're saying here, I can draw my hexagon. That's the shape of the base. Again, I'm going to make it a little flatter than a regular one so it looks 3D. Then you pick a point on top and just connect the corners. connect the corners, connect the corners, connect the corners, dot, 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 dot. So there are 6 triangles or 6 lateral faces, but there's only one base, which now makes this a 7-sided polyhedron, which is also a heptahedron. I only added 1 to the number of lateral faces because there is only one base in a pyramid. So the key thing is 2 with prisms and 1 with pyramids. Here's Euler's theorem. This is the theorem I was talking about earlier that compares the faces, vertices, and edges. And the way I always memorize it is just like this, is that the faces plus vertices always equals the number of edges plus 2. So we can take this solid here and count everything and see if it makes sense. So it looks like 2 rectangular pyramids, but pushed together. So really I could only touch the triangles, and how many of them are there? There's 8 faces, 4 across the top here, 4 on the bottom. How many vertices are there? Let's count. 1, 2, 3, 4, 5, 6. I just counted 6 vertices. Let's see how that compares to the edges plus 2. Edges, there's 4 on the top pyramid, there's 4 down the sides of the bottom pyramid, and then there's the 4 around the base where they're meet. That's 4 plus 4 plus 4, that's 12. And 8 plus 6 is 14, and 12 plus 2 is 14, proving, or I don't know if that's proving, but it's confirmed using Euler's theorem. My counting was correct. Cross section. A cross section is what you get when you slice into one of these polyhedra. And depending on which way you slice things, you get different cross sections. Cross sections are like a 2-dimensional section that you slice out. Let's see if this video will work, and I can show the video here. And then I can also post the link on the Edpuzzle, and this way you can watch it again. Hopefully this is working. All right, hopefully that sound just worked and you just learned a little bit about cross sections. I will link this into the Edpuzzle as well, so you can watch it again if you'd like. But it's just showing you that if you slice into 3-dimensional solids, you'll get 2-dimensional shapes. And I expect you to be able to kind of look at that and see what they're talking about and imagine how it would go. So you could see that if I slice this cube 3 different ways, I get 3 different things. This one I get a square, this one looks like I'm getting a rectangle, and this one looks to be a trapezoid. And then when I slice into these, well, I guess you could answer these on yourself. For this first one, what do you get? Yeah, it looks like they get a triangle. And then for the cone, that's right, it's a circle. And if I take this hexagonal prism and slice it parallel to the bases, I'm getting the shape of the base, which is a hexagon in this shape. Those are all kind of easy ones. I kind of like these better, where we're slicing into the same thing, different directions to see the different 2-dimensional figures that were formed. And I believe this is homework, so 12-1 is done. I look forward to seeing you in the next live lesson.